Welcome everyone to EA Global Summit 2021. This is Juhi from EA Global Summit organizing team. Firstly, thanks to everyone for your interest and for joining us in this session. This session is by Ju, Principal Architect from Sparx Services North America, presenting about how to build better systems using digital engineering. Kindly note that we will be muting all the participants throughout the session, and if any of you are having any questions during and after the session, please use the chat window or the questions window to drop your questions to the speaker. The speaker will answer the questions at the end of the session. To enable collaboration and communication with you and other EA practitioners after the session, we request you to visit the dedicated channel for this session in Microsoft Teams. The link to the Microsoft Teams channel is posted in the chat window for your quick reference. If anyone is having any difficulty in connecting Teams, please reach us in the chat window or write to us at registrations@eaglobalsummit.com. So thanks once again, and over to you, Gino.
Thank you so much for the introduction. And I'm going to try to share my screen, and then we'll start immediately.
Yep.
So I'm sharing now my screen. Can you confirm that it's working?
Yes, we are seeing your presentation now.
Okay. So thank you for joining. Today we're going to talk about digital engineering and how, rather than just building better systems, we should build systems better. And one thing that I would like to underline is, what are we talking about? We are talking about systems, and systems are not necessarily IT systems or software. Clearly, we'll talk about software, but I would like you to think about.
No issues. So நீங்க ஆபீஸ்ல வீட்ல இருக்கீங்களா?
I think the
Okay. Fernando session-உம் நீங்க எந்த session next host?
Hello, can you mute yourself, please, moderator? Thank you. So I was saying that we should think about building the system better, and the system cannot be necessarily a software system. And let's build into the conversation. So we are not in the modern art business. As you can see here in the 1500s, modern art was the Gioconda from Leonardo da Vinci. In the 1960s, we had a trending of new liberty, and it looks like in the 2020s, a lot of people believe that their job is to creating colorful visual diagrams. And because frankly, colorful visual diagrams are useless, other people believe that architecture itself, being a type of modern art, is useless. And so they claim, oh, we go agile, we don't need any of that. So we have these two big camps of modern art, creating colorful visual diagrams, and on the other side, practitioners that say, oh, I want to start coding, I don't need any architecture, I am so agile. And probably we need something different. And before I jump into that, let me introduce myself. I'm Gio Platania. I am in IT since a couple of years. I've been for 12 years with IBM GBS, and already in 2007, I realized a project with what was called on that time model-driven architecture. So model-driven architecture is basically the ancestor of what we're going to discuss today. Now, when I moved to North America, I was, 10 years ago, talking about how important it is to use models to drive your architecture. And people were saying something like, oh, I don't believe you. Now, in modern art, your taste and believing is important. In engineering is not. But today we are, moving toward a much more sophisticated type of architecture that is digital engineering. And while digital engineering has a lot in common with model-driven architecture, is not the same. So I'm living in Canada, in the middle of nowhere, with myself, my family, and 100 ships. And I like very practical things. I build things. I like things to work. But on the same time, I am an architect. I like to project things. And based on this personal taste is my intention to help the industry to translate ideas into something that is feasible. So, and what is the issue that we have? The issue is complexity. And simplified complexity is not the way in which you can manage complexity. And talking about complexity is the discussion about systems. And you see, most of people in IT believe that our concern is a system, like a piece of software. Today, I'm going to discuss about a very specific piece of software that has been created for the Department of Defense, the United States Department of Defense. And typically say, oh, my concern is this system. But then when you are kind of embracing the IT enterprise architecture, you understand that your concern is a system of systems. So because the collection of all your applications is creating a new system with new properties, such as nonlinearity, emergence, self-organization, adaptation, and feedback loops. And those properties are defined by the system theory. But then, if you really think about it, you know that the enterprise itself is another system. And this system is not only a IT system or technical system, but it's a social system. And very often that is the most important aspect that people simply forget. So if you don't think about the human aspect of the enterprise, how people is, focus on achieving goals that are not necessarily technical goals, you are losing your ability to succeed. And finally, we have also the industry, because the so-called environment of the system enterprise is the industry. So your clients, your suppliers, public opinion, the legislator, and so on. So and you see all of that is part of the concern, and creating architecture is trying to describe this concern. But how is that we describe this concern? Welcome to digital engineering. This guy to the right is Mr. Will Roper, that unfortunately is not anymore the Secretary for Acquisition of the Air Force. But for 4 years he was, and he was a real visionary, and he said that we need to embrace disruptive agility in order to remain competitive in a ever-innovating global security environment. Now, while he was concerned with global security, you can understand that in whatever industry you are in, we are in a very, very global competitive environment. So in his opinion, digital engineering is the key element of this new paradigm. And that is where the topic of the talk come in. Rather than just building better system, it builds the systems better. And if you think in terms of what I just said, the system is not a series of IT applications, but is rebuilding what is your enterprise. And that is what many people call the digital transformation. So from my point of view, digital transformation is building the system better, transforming the enterprise. And that means also at the end, producing a better application with better ways. And how is that we can do that? We can do that by doing better architecture. So better architecture is not creating modern art. Better architecture is creating architecture with the ISO definition. And you see that on the top. Architecture is describing the property of a system in its environment, embodies in its elements, relationship, and its evolution over time. Very often, when you ask people, even people with 25 years of experience of architecture, what is architecture, they don't know. But how precise need to be the description of the architecture? It's enough to give some hints of the architecture so that then we can have a human translating the architecture in something else like code, or maybe a business process that goes into execution manually, but still need to be understood from a piece of text. Maybe it's a Word document. Welcome to the digital twin. So what is the digital twin? The digital twin is a model that is so good that you can do a lot of things with that. And this model can be used in a system such as Enterprise Architect, but has certain characteristics such as connectivity. So connectivity means that the model is connected with this physical component and its digital counterpart. And it's a round trip type of connection. That is one of the different from model-driven architecture. Model-driven architecture, we have a top-down approach in which the model was informing the system, but not the way around. And in a digital twin, we have a complete bidirectional connection. The second aspect of the digital twin is the homogenization of data, decoupling the information from a physical artifact by abstraction. So in my example later in the talk, I will show you how we need to abstract technology and let only the concepts of the data inside our digital twin. The next aspect of a digital twin is that it's smart. So it's reprogrammable in an automatic manner. Now, we can use code generation for that. And today, code generation is done in a certain way. But we need to think about that in future, we may have also machine generating codes with machine learning and artificial intelligence. Digital traces. Twin technology leave digital trace, for example, a log, to inform back the model. It's not simply that we can import code or we can import information into static information and transform this information into models, but also the execution of the digital twin in the reality leave those traces, and we can use those traces to analyze the working of our digital twin and take decision. And next one finally is modularity. When we did originally model-driven architecture, we were always generating the complete system because the concept was, well, I don't care. It's a machine that is generating things for me, so I can generate the complete system. Today, we want to do better. We want to have a modular system, for example, using a microservice architecture. And in any case, whatever type of style of architecture we use, we want to encapsulate our system in a way that makes possible to redeploy a single element only without impacting the rest, so that we can have a continuous operation. Now, what is another different from model-driven architecture? In model-driven architecture, we have kind of a competition with other ideas such as agile. And today, we have this concept of the so-called the digital trinity. So what is the digital trinity about? Digital trinity is mixing up digital engineering, the agile methodology, probably most of you are familiar with, and open system architectures. We need open system architecture in order to realize the promise of digital engineering, and we need agile methodology in order to mix up the best of the agile with the best of open architecture. So we need to have authoritative virtualization and automation in this world, and only by using the digital engineering in the Trinity, we can achieve a measure of virtualization that can replace or automate or truncate, meaning reduce formally real-world activities. Now, this is my first example. Later on, we will jump into a story in which I will show you that all of that is real, but that is a concept. You can see that is a BPMN diagram. And basically, that is the most important part of the diagram. We are familiar with DevOps. We know that DevOps is a concept of unifying development and operation of software. But very often, architecture is not part of the DevOps. So digital engineering, in this sense, is attached to DevOps, creating something that we could call ArchDevOps or DevStarOps. So, and that is an example. So in EA, we create requirements. And when I say requirements, it's say extensive terms to indicate that we create the model. The repository contains the complex reality of the model. And later I will show you the different layers on aspect of this model. But what can we do with this model? So not that we simply take the model and we generate some code. We can use the model to inform decisions. For example, we can simulate the UI by wireframe simulation. We can simulate business processes by using process simulation. We can simulate business rules by using rule simulations. So we can decide even before we start developing anything if an idea is good enough by saving a quantity of money and time. The next step is by generating in the model user story and code, and then we can push this information downstream. So the user story, for example, can be pushed into Jira, and the code can be pushed into any IDE, and that is where the coders, the developers, start to do their manual work. Now, very often people say, okay, how much % of code we can generate? Now, in the project that I did 11 years ago, we achieved a 90% of code generation for a very complex platform that was deployed in Germany nationwide for managing of the smart grid. But that required a substantial investment of not only money into the system, as we will see, but also a substantial investment into your team. But after that, you start generating the code. You can mix up different Jenkins, and as you know, Jenkins is a continuous integration system. You can have Ansible and Sentry monitoring and deploying things and so on. And then you continuously iterate that till you achieve a certain stage of your application. Now, all of that is simple, but don't tell us everything on digital engineering. Because digital engineering is more than software development lifecycle. The concept is if we want to create a digital twin, and this digital twin is a twin of the system that is the enterprise, we need to include in the model aspects that they have nothing to do with IT. So this model will include aspects of enterprise design, including business planning, business architecture, enterprise architecture, solution architecture. And then we go down to the solution development. And that is where the typical software development lifecycle happens. And then in a portfolio program and project management, that is where we start to do the DevOps cycle. So as you can see, the aim of digital engineering is way bigger that it is, a simple DevOps plus, because we need to include also the real decision makers into that. And we need to provide them with the ability to translate their vision and their idea in something practical and not anymore having PowerPoint that is useless. Because modern art is not only done by architects, a lot of modern art is created by decision makers, by leaders that believe that they can really translate any PowerPoint in something that really works. As you can suspect, I work for Sparx Services North America, and so I'm proud to say that Enterprise Architect is one of the leading IDE tools. And IDE tools is an integrated digital environment, so it's not only for developing code, but it's also for development of the whole system. So what you see is a screenshot for a document that you can download online. Is the so-called digital building code that from now on, every new project that want to be called a e-project has to respect, and Enterprise Architect is one of the tools that is named. However, the real issue is not having the tool. The real issue is your organization really ready for all of that? So, and that is another screenshot from that digital building code. So here you can see that they know that if employees don't have the modeling skill and data stewardship, if they are unable to use the system, we are not going to succeed. And recently, another leader in the Air Force, so Nicholas Chelan, Air Force Chief Software Officer, left saying that we have the good ideas, but we don't have the right people on the top of that. You cannot simply put a major or a colonel on the top of a very technical project because they are good in order type of activities. We need to have skilled people that take charge of it. Now, that may be true for Department of Defense only, but frankly, my experience is very true also in commercial and private organizations in which people that are good leaders in general, they don't properly understand all those concepts and they believe that they can bring a organization to success by using old style school approach to how we manage and transform organizations. So that is why we have created this program that we call Architecture in a Box. So we believe that the tool is the last of your concern. We need to understand what is that you really want to do to create a system of elements, a methodology to train your people and so that they have the proper skill, and also to tailor the tool to all of that so that support exactly the style of digital engineering that you intend to use. And here we have again another screenshot from this digital engineering code. Ensure that your organization is ready for digital engineering. So Architecture in a Box is a program for digital engineering readiness, but it's also a program that will start from the bottom of what we call the maturity level, because depending where you start, you may achieve very quick, very high result, or you may require a certain time of ramping up before you can really understand how things can work for you. Every organization is different, and we cannot simply reuse for all organization what has been successful in the past. However, we know what elements need to be there in order to pass in each of the domains that you are concerned with. So skills, methodology, taxonomy, and culture and tooling. So to pass from a level 1 maturity to level 4 or 5. And level 4 or 5 is where you really achieve a high level of automation in your enterprise. Okay, this is my high-level introduction, and we will dedicate the rest of the session to a practical application of that. And I would like to tell you the FreeTax Server story, a digital engineering tale. As I said, already in 2007, I did this project. It's called Olympus. You can go still and download it. This project includes elements of a web IDE that create a model, and then you press the button and you transform this model online in a web application without ever leaving your browser. That was in 2007-8 revolutionary, and since that I've seen very, very little evolution. That's why I'm so excited to introduce you the new incarnation of that is the FreeTax Server. So what is FreeTax Server? So the Department of Defense has this thing called a COT, that is for Center of Target, on Target. It's a series of concepts to describe the situation on the battlefield. However, that can be used and is being used for any type of situation that include or require situational awareness, meaning what is around me, what is happening on a map, basically. So, and the Department of Defense has invested heavily in this technology and has created this amazing set of applications. So we have many clients such as WinTAC, iTAC for iPhone, AirTAC for Android, and XTAC. So we have clients for your watch, we have clients for the web, and on and on and on. And all of that is implemented in several technologies by different teams in different places. And they have a central server. So when I started to think, all of that was super military secret. And I said, oh, that is cool. I want to understand how that works. However, the complete specification was missing. And was not missing only because it's a secret, but basically because in the years creating all this legacy applications, no one had the time to create any type of architecture or documentation. And as a consequence, right now, this is maintained with a lot of manual effort and frankly, super expensive to maintain. So what I, with some other people, we have done is we took our secret sauce and we approached that with DevStarOps, aka the digital Trinity, and by using that concept or Sparx modeling platform, we were able to recreate super quick a new server. So think about it, the TAC server, the legacy TAC server has been created in 15 years of work by a major defense contractor, and the expense has been extremely high. And what we have done is we have recreated this called free TAC server. We have used the digital Trinity. We have maintained, and we do maintain, a model that is composed by UML plus Archimate extended. That is another thing. You cannot simply jump in and start using SysML or plain UML to create such a model. You will need to create your own custom extensions, your own domain language to define that domain. And as a consequence, you have a system that you can not only deploy on a server, but you can deploy on an Android phone, a Raspberry Pi, cloud server, Android tablet, you name it. And you will ask, okay, so they took 15 years to do that. How fast have you done it? So that is the roadmap. So basically, when we started in February of 2020, at the beginning of the pandemic, and already in June, we had a working version of that. And in August, we released the first stable version. And since August last year, we have basically deployed a new version more or less every second month. And the clue is, and the most important thing is, me and some other people, we have done most of this work in our free time. So basically, we took very little time to recreate all of that. And one thing that I'm especially proud of, certain functionalities like federation here, you know, the original architects of the legacy system, they say it's impossible that they will understand or replicate that functionality because it's so complex. And we did that in a couple of weeks. And now the reason why you can do that, you can do something like that is because you can import code into the model. You can use the model, your digital twin, to analyze how is the structure of the code, separate the data that is relevant from its technology, and then to redeploy into another technology. So we have achieved 90% of the functionality of the legacy server with a fraction of the cost. Really, we have done it with peanuts. So how is that could be even better? Currently, we use our conceptual TAC model, you see here, That is our digital twin. We have a platform independent architecture here, and we can deploy it with a single server that is a FreeTAC server. But conceptually, something like that could be used to maintain the complete program, meaning we will have, stakeholders such as product manager working with Prolaborate, creating high-level requirements for defense, for home security, for emergency management systems, and so on. The conceptual requirements are translated into more technical conceptual models, and those are translated into implementation models, and those implementation models are generated in clients and different servers in different technologies and so on. All of that is possible if you applied a digital engineering with a digital Trinity application. And by the way, all of that, a similar approach is required by the new digital building code of the DoD. And previously we have seen a way in which by role we separate the models. That is a different approach or a view on the same. You see, that is inspired by TOGAF Enterprise Continuum. And here we have the separation between the industry architecture. Here, the reference industry architecture will be DODAF. Then the organization architecture is connected to the industry architecture. So we have the organizational canonical model. In the sense, the code, the center of target domain model is the one that is referenced to that. And this is a so-called PIM in model-driven architecture terms. This is translated to a PSM, so a platform-specific model. So we are still in the model. So the PSM here is the implementation layer in this screen. And finally, that is generated into code. Again, that is a view of model-driven architecture that don't yet take into account new concepts coming from a digital engineering approach, explaining that you need to inform your digital twin also with the result of your generation. So to have a feedback directly into your digital twin coming from the code. So, and then we were talking about open systems as part of the digital Trinity. So that is our proposal to the future tax server, in which we are going to embrace a better application of open architecture by having a domain-driven design and domain-driven design APIs with independent services to be more scalable, more flexible. That is what we are planning for FreeTAC Server 2.0. And all of that will be very complex to do in a monolithic system and is very easy to do in a digital engineering system. So from what I know, the legacy tax server team is trying with a huge effort to go toward such a architecture, and it's extremely complex because it's extremely complicated to separate what they have done from the technology. And here you see we have already, as in this example, the fact that each microservice is deployed in another language, so it's language independent. Now, today, that is how the FreeTAC server works. So we have the FreeTAC server model that is divided into categories. So we have the use case model as a representation of a business model that generate user stories, and a so-called controller model that is the behavioral model, and that generate controller. So we are currently using a model view controller pattern. I know it's not the most modern one, but remember that we have done most of that in our free time. And then we have the structural model, the code model that generate the domain model, and that is generated into Python. And additionally, from the structural model, we generate also interfaces. This is another very interesting thing of a tax system. In times, a tax system was extended. They started to by using XML in the early 2000s, and then they went to protobuf and JSON, and now they're using a mix of all of that. The issue is, if you look at the current implementation, all those interfaces should express the same concept, but they are not, because they are implemented separately by separate teams, as I said before. So the advantage of digital engineering here is we have a single model, and that model defines what is the interface, and then we add here in the interface code only the technology-related elements. And finally, from the same model, we can also supply a full-fledged documentation. As you know, EA is very capable to generate documentation from the model. Now, let's go a little bit more in detail of it. So in this project, we start by defining the business model. Then we transform the business model into behavioral models, so-called code verbs. For each use case, we have a controller, and this controller contains a set of functions, and these functions are then implemented manually by developers. Then we design the domain model, that is, the bones. This is the muscle of the system. This is the bone of the system. We generate the application in Python. We generate the interfaces with XSD, JSON, and protobuf from a single model. So that is how the behavioral model works. So you start with the definition of a use case. Then from the use case, you generate, so we have scripts that generate from the use case a controller. And if inside the use case you have a activity diagram, such as this one, the controller will also contain functions that are related to the activities in the activity diagram. And that is the generated code that you can see. So this is the main piece of work. That is the structural model or the code domain. This has been created by analyzing current code. So by importing into the model XSD files and JSON files, but also by reading existing documentation or code and translating all of that without any technology into an abstract UML plus model. And when I say plus, is those classes are stereotypic classes and contains additional properties that you will need for code generation. We use that model and the EA Schema Composer to generate the interfaces. So interfaces are very important nowadays because the interfaces are providing the ability to create an API. One thing that we have done that is new and the legacy server could not easily provide is the domain model has been not structured really in a object-oriented fashion, has been structured originally in XML. And because of that, is not superhuman readable. And in order to do that more human readable, we have created this JSON interface that transform verbs and objects in something that each human can understand, instead of messing up with a complex military terms and very, very technical terminology. Another thing that we have done is we have also created the design into the model. You see on the left is a wireframe design of the application, and to the right is the JavaScript code. And you can see it looks pretty cool. That is the interface that we currently use since version 1.5, and is a single page application that access to the backend by using web services. And as I said, all of that is possible thanks to digital engineering. As you can suspect, we also use Prolaborate for project management. So the complete model you see here, the use case that is created as a business model. We have also a definition of the different versions as stages in a roadmap with the status. We have here the use case Kanban that we use to say what is that we have implemented. And we have here a chart indicating how much we intend to implement and so on. Oops. And that is, the end of the story. What is the conclusion? So let's think about what we have learned today. First of all, are you ready for digital engineering? There are a lot of decision makers that believe, or maybe they hope that buying a tool such as Enterprise Architect is enough. They said, oh, we have a very, very good team. They are so smart. They will figure out how to use it. Now, indeed, the tool is crucial. However, the real question is, do you have the right tool, and is this tool integrating with the rest of your infrastructure? But the central point is culture and skill set. So if your enterprise, for example, is based around silos, and each silo is thinking in its own terms, and they have their own goals, and they don't care about what happened upstream or downstream, it's really, really difficult to collaborate. And if you don't extend the concept of the model across those silos so that we have a single language across the different jobs and departments, it's very, very difficult to leverage what you have created in a part of the digital twin in the next part of the digital twin. So you can start from the top with planning. You can start from the bottom with solution architecture and development of applications. But very often you will discover that the big picture, the trip is to increase your maturity by changing the structure itself of your organization by investing into skill set. Another thing is the methodology. It's not only a methodology for developing software. It's a strategy for digital engineering at an enterprise level. Everyone, including top management, in their own viewpoint, need to be informed about that so that they can take advantage of the ability to translate their own ideas very quick in something that is visible and bring value to the enterprise. And also another thing is, if you have 10 different ways to do the same, you don't have consistency in your methodology. So unfortunately, one of the downside of this approach is that in modern art, if architecture is a form of modern art, you have a lot of freedom to express yourself. But if we are doing engineering, you have to be very precise in each single part of the model, not diagram that you create. And that requires a very, very high level of skill, requires so that to be supported by a certain culture, such as the appreciation of the time that you need to create this model because you know what is that you get back from the digital twin. All of that need to be part of your culture, need to be part of the training, need to be defined within your methodology, and only at the end need to be supported by your tool. So as I said, I work for Sparx, but the tool is the last of your concern. If you have a perfect culture, a great mindset, and the best of the methodology, in theory, you can do that without our tool. You can do that better with our tool, but it's not the most important part of it. So, in conclusion, digital engineering allow for faster, easier, and more robust, flexible integration with third-party system that the existing software does. It can ensure that technology is aligned with the business intention. Very, very important, because very often it's not the case. One of the disciplines that we cover is business architecture, and I can tell you, business architecture is, even when it's very mature, a struggle to connect the intention with the realization. Digital engineering is not yet another hype. It's based on the merging of 20 years of best ideas, and that includes model-driven architecture. And as I said, I was using successfully model-driven architecture years and years ago. Our tool is supporting model-driven architecture since the beginning. Agile methodologies, open system architectures, and frameworks that has been created in the last 20 years. So the IDE, the integrated digital environment, is crucial, but it's not enough. So that is what we offer to you. We offer our expertise to help to improving the way in which you work, so that we can help you to support in the digital transformation of your enterprise. And that is the end of my presentation. I left some time for questions, so if you have any question, feel free to ask now.
Thanks, Gio. As of now, no questions from participants. Maybe we'll wait for a few minutes to drop any questions from participants in.
Okay, in any case, if you have any question, feel free to use our Teams for that. Additionally, for questions that are related to the project FreeTax server, that, as I said, is open source. We have a Discord and a Reddit online. It's a free community. And as I said, I don't do that as part of my services for Sparx, but as part of my personal interest. So feel free to have a conversation there. It's a very big community with over 3,000 members. And also I am on LinkedIn, so you can find me on LinkedIn. So feel free to connect and ask questions. And thank you for joining me in this tale on digital engineering. And I hope we will do something together in future. And if not, have a good experience with digital engineering and not with modern architecture. Thank you.
Okay, so there is a question from Tom asking about what ways can EA help with digital engineering out of the box?
So what is EA doing out of the box? For example, with EA, you can use directly the Schema Composer. So as you can see here, we have a class diagram. And if you have a class diagram with the Schema Composer, you can directly generate XSV and JSON. And if you have certain script capabilities, you can also extend the Schema Composer to generate stuff such as protobuf, and that is what we have done. Other thing that you can do from the same class model, you can generate the envelope of your classes. So that will give at least developers a certain interface, and they will need to implement their code within the interface that is defined inside the model. That is not high level of automation, but is allowing you to have much better control of implementation. Any other question?
Yeah, there is another question from Michael asking how hard is it to make the staff ready for this kind of modeling?
That is an excellent question because basically that is the topic of this talk. How hard is that? If you want to achieve a super high result tomorrow, probably you are going to be disappointed. This depends a lot on where you are starting with. And when I say you, it's not a single individual, but it's your organization. Clearly, if you are a single developer and you do everything by yourself, it's different that you are a big organization such the DoD, or currently one of our major clients is one of the top 5 banks in the world. So you can understand the complexity of having hundreds of people that are doing architecture changing their way. So what we do is we typically assess the maturity level, and we assess the maturity level in each of the domain, and then we propose a step-by-step increase of the maturity level. So if you are already super good, let's take the simple example. So you are a single developer and you want to embrace digital engineering only for yourself. You buy EA and you have an excellent understanding of languages such as UML. And when I say languages, it's the language, not the diagram, okay? So you understand how a model works, you understand object orientation principle very well. So you are already, kind of level 3 of the maturity. And then you want to go to level 4. So you start to use EA as is, then you create your MDG that is extending EA with special properties. You start creating your own template for generation so that you can generate code that you want to generate. You start to create scripts for model-to-model transformation, and you are level 4. And then you want to go level 5, and then you need to do much better. And that is what we are doing right now at Sparx System North America. We're investigating how to use machine learning to inform the model. So we want to have a spider going through your code, your file system, your enterprise, and gathering information and informing your digital twin. And that is nothing that you can do easily, okay? But that is, will be level 5 of the maturity. However, if you have, a level of, I am a script kid, I can write a little bit of code, but my code is not really object-oriented, and I want to use digital engineering, that is not the problem of digital engineering. That is the problem that you will need to invest a little bit in improving the quality of your understanding of what is really object orientation. And for example, another thing that very often developers miss is the principle of object orientation that frankly are in common across all the languages. So you need to detach yourself for the language from the technology and understand how all those languages, all those frameworks have certain principle in common. And then you can move to the next stage of the maturity.
Thanks, Ju. So there are a couple of more questions too. My team is already pasting those questions in your MS Teams channel, Sparx Services North America channel, so that you can take forward the conversations with participants directly.
Thank you. I will. I look forward to it.
Yeah. So thank you, Ju. Thanks to everyone for your time during the session. Hope it is very informative and give deeper insights in digital engineering. As said, Ju will be available in MS Teams to have a detailed discussions and answer more questions. The link to Microsoft Teams is pasted in the chat window for your quick reference. Thanks once again, everyone. Looking forward to hosting you all in another wonderful session at this summit shortly. Thank you, everyone. Thanks, Ju.
Thank you.